Let's prepare on the TRB Polytechnic exam 2017 Civil Engineering question paper. Question number 131. The eigenvectors of the matrix M is equal to 4, 3, 2, 9 or what? So here the matrix A is given as 4, 3, 2, 9. So first we want to find the eigenvalues here. So it is A minus lambda I is equal to 0. So I is nothing but it is a unit matrix. So it is 1, 1 and the 0, 0. So if you do this, then you'll get A minus lambda 0, 0 lambda. Like that you'll get two matrices. So when you minus, so subtraction is the normal subtraction only in matrix. So if you normally minus that, you'll get 4 minus lambda, and in the next term 3 minus 0, and in the third term 2 minus 0, and in the fourth term 9 minus lambda. So this matrix you will get here. So now this is equal to 0. So you can find the determinant of this matrix, and so that you can find the lambda easily. So here to find the determinant, what you should do is you should multiply these two terms and minus of the multiplication of these two terms. So first, that is 4 minus lambda into 9 minus lambda. So that will give you lambda square minus 9 lambda minus 4 lambda plus 36. You will get then minus 2 into 3. So you will get minus 6. So on simplification, you will get lambda square minus 13 lambda plus 30 is equal to 0. So now we can use this t method to find the values of the unknown, because here the first term is having x square only. So you can use this method. So you just take a t method and you have to take the values, that is the multiplication of the first term and the last term, that is the coefficient of x square into the constant value. So here we have plus 30, and the middle term, that is the coefficient of the x term, is minus 13. So that you should write it here. So plus 13 minus 13. So you should write the values here such that the multiplication of these two values will give this answer, and the addition or subtraction of these values will give the bottom answer. So such that you have to allocate some values here. So here minus 10 into minus 3 will give you 30, and the addition will give you minus 13. So let us take lambda minus 10 into lambda minus 3 is equal to 0. So that will be the simplification of that equation. So when lambda minus 3 is equal to 0, lambda is 3. When lambda minus 10 is equal to 0, lambda is 10. So here the lambda values are 10 and 3. So now we have got these values. Now what you should do is you should substitute these values in the formula which we have derived in the first, that is with the lambda we derived now. So in that you have to substitute, and you have to multiply it with x1 x2 matrix. So now you will get the eigenvector here. So this is the next step we are going to do. So in the matrix we saw that it is 4 minus lambda and 3 and 2 and 9 minus lambda. No. So first we are taking the 10 value alone. So here 4 minus 10 and 9 minus 10. So now you will get minus 6, 3, 2 and minus 1 into that vector, that is into that matrix, that is x1 and x2. So on multiplication you will get minus 6 into x1 plus 3 into x2. That will give you 0. And the next equation is 2 into x1 and minus 1 into x2. So here you will get two equations here. So now we have to find the k value, that is we can equate this equation to k, that is minus 6(1) plus 3x2 will give you k. So you can write minus 6(1) is equal to, you can take one term to the next side, that is minus 3x2 is equal to k. So from this you have to find the x and x2, that is x1 and x2 values in terms of k. So if you see here, this minus 3 and minus 6 term, we have to bring it to the bottom so that it is easy for calculating the k. So x1 by minus 3 and x2 by minus 6. So in the both the side, if you are having minus, so you can neglect it. So I have written as 3 and 6 here. So x1 will give you 3k and x2 will give you 6k. Okay. So the x1 is 3k and x2 is 6k, which is of divisible by 3, no? So I have divided it here. So it is 1 and 2. So x1 will be k and x2 will be 2k here. So that the eigenvector is 1 and 2. That is the coefficient of k will be your eigenvector. So here 1 and 2. So 1 and 2 is the eigenvector. So this is of one vector only with the lambda value 10 we have found it. So you can see in the options, if this 1 and 2 is there in one option alone, means you can directly go for that option. You don't need to find the second eigenvector. But if 2 or 3 options are having the same eigenvectors, means then you have to do the second option also. So now let us do the second option also, that is lambda is equal to 3, no? So with that also we can find the eigenvector. So here 4 minus lambda, that is 4 minus 3, then 3, then 2, and 9 minus lambda, so 9 minus 3. So you will get 4 minus 3 is 1 and 9 minus 3 is 6. So x1 plus 3x2. So that is your first equation, and 2x1 plus 6x2, that is your second equation. So you can take any one equation. X1 is equal to minus 3x2 is equal to k. So x1 by minus 3 is equal to x2 by 1 is equal to k. So x1 is equal to minus 3k and x2 is equal to 1k. So the coefficients are minus 3 and 1. But in the option they have given 3 minus 1 only. Okay. So if in these cases you should be known that the minus, if that is minus in one term alone, means it can be in other term also. So only the ratios we have to see here, and you should not see that minus here. Because in this formula, that is in x1 is equal to minus 3x2, no? So you keep like this. In this we may also do like this. x1 by 3 is equal to minus x2 by 1. So like this also we can keep. So if you keep like this, means the answer will be 3k and minus k only. So at that time it is 3 and minus 1. So here in this cases you should not see the minus value, you should see the ratios of the k only. So the eigenvectors will be varying like this also. Okay. So now we have got two eigenvectors. So here we have got this option 1, 2 and 3 minus 1. So as I said before, if you are finding the first eigenvector, that is 1 and 2 means alone, it is enough for this question, because only one option is having that value. So you can go for that. Thank you, and keep watching for the continuation of this question paper discussion.